Hello, class. Welcome to this lesson. Just a quick, lesson on, the homework. So we're just going to be going over the practice problems in case we're having a tough time with them. I wanted to make sure I, cover a few things. So let's take a look at the first one. So we have, and this is the 8.1 part 2. So this inferential statistics is the branch of statistics concerned with drawing a conclusion about a sample characteristic. So remember that the inferential statistics from your notes. This is coming from your notes. Inferential statistics is basically when you're trying to make an inference about the value of a parameter. So you're trying to draw a conclusion about a parameter. Remember, you're trying to figure out what the parameter, the population is based off of the sample. Okay, so we had to take a sample to get the population number to estimate it. Here it's saying that it's concerned with drawing a conclusion about a sample. We're not concerned with drawing conclusions about samples. We're concerned with drawing conclusions about populations. Okay, so population characteristics. So this is false. In the hypothesis testing process, the decision is always made in reference to the null hypothesis. So remember that when we make a decision, it's always reject the null hypothesis or fail to reject the null hypothesis. So therefore, this is correct. The decision is always made in reference to the null hypothesis. The directionality of a test is dependent on the research hypothesis. So the research hypothesis is the same thing as the alternative hypothesis, HA. So remember that if you had H0 and H1, for instance, let's say mu is equal to 5, mu is greater than 5. Well, based off of this hypothesis, this is a right-tailed test. And this is because you're looking at the alternative hypothesis or the research hypothesis. This looks like an arrow pointing to the right, and therefore it is a right-tailed test. All right, and you're looking at basically the alternative or the research. So this is actually true. Directionality is dependent on the research hypothesis. If the p-value is exceptionally small, this means we have to conclude that we have to do what? So if the p-value is small, so remember, if the p-value is small relative to your level of significance, if it's less than or equal to, remember that means that we reject the H0. If the p-value is greater than alpha, we fail to reject the H0. Okay? So if the p-value is really small, which means you're looking at less than or equal to, it's going to be reject the null hypothesis. The conclusion made in the last step of the hypothesis testing process reference to what? So remember that the decision sorry about that. So remember that the decision is always either reject H0 or fail to reject H0. Whereas the conclusion is based off of the claim. So remember, when we do the conclusion, we always say there is enough evidence or there is not enough evidence to reject or support the claim that ... So the conclusion is related to the claim, decision is related to H0. So the last step in the hypothesis testing must be made in reference to the claim. A p-value that is large indicates that if the null hypothesis is true, the result you obtained could be due to chance. So p-value that is large. So p-value that is greater than alpha means you fail to reject the null hypothesis. So basically this is the definition of a p-value. So if you have a p-value that is large, this means that you're failing to reject the null hypothesis, which means that it's probably going to be true, right? So we're going to say well, you're failing to reject it, which means you don't have enough evidence. So we don't know if it's true or not, but we just don't have enough evidence to say it's false. But the definition of the p-value is that you will always assume that the null hypothesis is true. So for p-value, you always assume H0 is true. Kind of like you assume that you're innocent until proven guilty. You're assuming that that's true. Now, if that is true, what are the chances that you get that result or something more extreme? So if, for example, I got a p-value of 0.05, this means that if the null hypothesis is true, that means that this result that I obtained is going to be, the probability of getting that result or more extreme is 5%. Okay, so if I'm failing to reject the H0, this is saying that the result I obtained could be due to chance, and therefore we fail to reject. All right, so basically, if something can be due to chance, that means that it's probably just a fluke, right? So it's probably just something that occurred due to chance. And if that's the case, that means you don't have a strong set of evidence to overturn the null hypothesis, unfortunately. Okay, so if it's due to chance. Now, if you say that it's not due to chance, then that means you have enough evidence. Okay, so p-value that is large means you don't have enough evidence, which means it's due to chance. So this is actually true. By default, the p-value is obtained by assuming that the null hypothesis is true. That is true. That's what we said earlier. For the claim, the proportion of students who change their majors in college is no more than 53%. What is the directionality of the test? So our claim here is that the proportion, p, who change their majors is no more than. No more than means less than or equal to. Okay, so not greater than 53%. So 53% is 0.53. So that's our claim. This is a statement of equality. So this means this belongs to the null. Which means our H1 is going to be the opposite of that. It's going to be greater than 0.53. And remember, H1 determines our directionality, right? So that guy right there. So therefore, if you look at here, oops, I apologize for that. So if you look here, this is a right-tailed test. Just looking at that sign. All right, so we have a oops, I'm looking at the wrong one. Right-tailed test. Now, number 9, consider the claim that the proportion of high school dropouts is at an alarming 20%. If you, the researcher, believes that if you believe that the result is too high, you would have to conduct a what test? So here the claim is you said that the claim is that the proportion is 20%. So therefore, if the result is too high, you believe that the result is too high. So okay, so this belongs to the null because it's a statement of equality. It says you, the researcher, think that it is too high. Because you think that the result is too high, that means that you're really saying that it should be lower, right? So if you're saying that it should be lower, then that means you're saying that you think it's going to be lower than 0.20 because you think that the 0.20 that they say is too high. All right, you're thinking it's probably more like 10% or 15%. All right, so that's your research hypothesis. So therefore, it is going to be a left-tailed test. If you look at this symbol, that looks like a little arrow pointing to the left. So left-tailed test. Suppose the p-value is large in relation to the significance level. The claim was that the average American has a BMI that exceeds 26. For the last step in the hypothesis testing process, we should conclude that there is blank evidence to blank the claim that the average American has a BMI exceeding 26. So let's go ahead and write our claim. It says the claim is that the average, which is mu, American has a BMI that exceeds 26, so it's going to be greater than 26. This is a statement of inequality. So this actually belongs to the alternative hypothesis. Which means that the null hypothesis is going to be the opposite of that right here, less than or equal to. So that's the null. So this here is our claim. Okay, so since that's our claim, that means that we're going to be using the word, if the alternative is our claim, we have to use the word support. Okay, so for our two blanks, support the claim. If H1 is the claim, we have to use support. If H0 is the claim, we use the word reject the claim. If now in this case, are we going to reject or not? So it says here the p-value is large in relation to the significance level. So they're saying that the p-value is greater than alpha. This means that we fail to reject the null hypothesis. So if we fail to reject, we're going to say that there is not enough evidence. Okay, so fail to reject, not enough evidence. Reject, that means you have enough evidence. Okay, so the conclusion here is that we conclude that there is not enough evidence to support the claim that the average American has a BMI exceeding 26. All right, let's look at number 11. We're almost wrapping up here. Perform a hypothesis test for the following study. The average 1-year-old is 29 inches tall. A random sample of 31-year-olds was obtained. The test statistic was 2.51. At the 5% significance level, can it be concluded that the average height differs from 29 inches? Assume the data is normally distributed. All right, so for the first step, we have our, what is the first step going to be, basically, is what they're asking. Okay, so we know our claim is that the average 1-year-old is 29 inches tall. That claim belongs to our null. And then it says, it doesn't give you any information on what the researcher thinks, so we're just going to say it's not equal to. Okay, so therefore, equal or does not equal to. Once you submit this, they'll actually give you more problems. So this should actually, now that I think of it, give you more problems. Okay, so I don't know if you see this on your end, but there's actually more questions to the. So if you don't have this, well, these are just going to be bonus questions for you. It's weird because when you select an answer, it should give you another part, another question for another part. I'm not sure if that happened on your end if you only got 12 questions, but there are actually multiple parts because you got to do a hypothesis test. So I guess basically these are going to be some bonus questions if you don't have this. Okay, so basically the first step is you have equals, not equal to. That's what we said earlier. Okay, so we got that. Now next we want to perform a hypothesis test for the following study. This is the same exact study. So in this example, the claim belongs to where? So in this case, the claim belongs to the null. So that's pretty easy. You say that the claim belongs to the null hypothesis, H0. Perform a hypothesis test for the following study, same study. So it says, in this example, what is the direction? Well, the direction has to be, if you look at the H1, that tells you the direction. So this is going to be a two-tailed test because it's not equal to. So you're going to select two-tailed test there. For 14, perform a hypothesis test, same deal. For this example, what is the p-value? So use 4 decimal places in your response. So how do we find the p-value? This is going to be on the quiz, so I want to make sure that you look at this. So it says assume the data is normally distributed. So on the quiz, they're going to ask you, what is the p-value of, the study. So here to find the p-value, you're going to be using the z-chart. Now they tell you that the test statistic is equal to 2.51 in the problem. This test statistic is our z-score. Okay, this is our z-test. We call it z-test or zt. So this is the z-score for the test. So we're going to go to, let's go to the z-chart, and actually we know that it's a two-tailed test. So let's go ahead and draw the normal distribution. So we're going to draw a normal distribution. We know our z-test is 2.51, so that means 1, 2, 3, -1, -2, -3. So we have our 2.51 somewhere over here. Now, since it is a two-tailed test, you're going to do the negative version as well. Then you're going to shade your two tails, and that's my p-value. So to do the p-value here, we have to double whatever the area is on one of the sides. So let's figure out the area to the left of negative 2.51. To find the area to the left of negative 2.51, I need to use the z-table. So let's go ahead and use the z-chart. Remember, the z-chart gives you the area to the left. So if I looked up negative 2.51 on the table, I can just use that area. If I look up 2.51, however, be very careful. You're going to have to do 1 minus, and that's because you want to find the area to the right in this example. However, let's make it easier on ourselves. Let's look up negative 2.51, and then that'll be our area here. Okay, so let's go and look up negative 2.51 on our z-chart. So I will definitely suggest having a z-chart readily available. You can look this up on the web. The web has z-charts at your disposal that you can use. Otherwise, you can use the files. I should have the z-chart on the files tab, if I'm not mistaken. Otherwise, I will include it in there. So we have negative 2.51, so that's my area, 0.0060. All right. So this is 0.0060, which means that this is also 0.0060. So I basically got to double that p-value. So I got to double it because I got two of those areas. And that gives me 0.0120. So that's going to be my p-value. You only double it if it's for a two-tailed test. Otherwise, you just pick the value that you found, okay? So that's my p-value. Perform a hypothesis test. The same test. Based on the results, what should we conclude? Do we reject or fail to reject? Well, we know the p-value is 0.012. Remember, if the p-value is less than alpha, we reject, or less than or equal to. So our p-value is 0.012. That's less than or equal to, well, what's my alpha? Well, they said it's a 5% significance level. So alpha is 0.05. So is this less than that? Yes, it is less than 0.05. So therefore, we reject the null hypothesis. So we're going to reject. All right. So then what's our conclusion? So our conclusion is that since we're rejecting, that means we have enough evidence and then we're going to say reject. Okay, so I'm sorry, reject. We have to look at our claim. Let's look at our claim. Yes. So since our claim belonged to our null hypothesis, we used the word reject. Otherwise, we use the word support. To reject the claim that ... Just write out the claim. All right. So those are my two key terms there. Find the p-value for a two-tailed test and a test statistic of -1.83. assuming a normal distribution, z-table. Use 4 decimal places for your answer. So our z-test is negative 1.83. So we got to look that up. Now this is a, it says a p-value for a two-tailed test. So we have that means that we have negative 1.83, but we also have positive 1.83. So we got to figure out the shaded region. So let's look up this region using the z-chart, negative 1.83. So negative 1.80123, so that's going to be 0.0336. So this is 0.0336. I want to make sure, let me double check that. Yep. Which means this is also 0.0336. So basically, since it's two tails, we double it. So the p-value is 2 times 0.0336. Okay, whatever that is, you just got to double it. Let's actually do that real quick. So 0.0672. All right, so that's my p-value. Find the p-value for a right tail test in a test statistic of 1.33. So this is a right tail test now, and that my z-test is 1.33. Since it is a right-tailed test, this means I shade the tail to the right. All right, pretty obvious. Now to figure out this area, we need to figure out this area. So to figure that out, we need to look it up on the z-chart. But remember, since the z-chart gives you the area to the left, we need to do the area to the left, subtract from 1. And that'll give me the area to the right. So look up the z-value, look at the chart, and then subtract from 1. So this is my z-test. So let's look up the 1.33. I need to go to the positive side here. Okay, so let's go to the positive side. 1.33. So it looks like 0.9082. All right, so 0.9082. Let's go back. So this right here is 0.9082. But to figure out the right side, I need to do 1 minus, right? So 1 minus 0.9082, which is 0.0918. Okay, so that should be my p-value. All right, now find the p-value for a left-tailed test. So again, got our left-tailed test. Our test stat is 0.87. Remember that in the middle you have 0, and then you have 1, 2, and so on. So that means 0.87 is somewhere around here. So we need to shade the area on the left side. This is a big left tail, and that's because we have a positive value and we want to do a left tail test. So we got to figure out all of this area. So therefore we're going to look it up on the z-chart and do nothing to it because it's on the left side. So 0.87 0.87, it's going to be 0.8078, and that's going to be my p-value, which is right here, the correct answer. All right, that's going to be it for the video, guys. I'm sorry, I apologize for, I don't know, that little glitch there. I'm not sure why, if it showed you all the problems or not. But I hope this helped, and I keep studying these types of problems. They're going to ask you p-value. They're going to ask you the different steps in the hypothesis testing process, like going through what we did, and so on. All right, guys, I'll see you in the next video.